And now, ladies and gentlemen, it is 13:40. Please welcome on the stage, Serial Seb. Awesome. There you go. There's even an alarm to tell me that the show is starting now. All right, let's make sure I'm in Do Not Disturb. Okay, how many of you have been to my talks before? Okay, good. You're all new. I apologize in advance. We're going to talk about REST 3.0. How many of you think it's a link-bait title? Very good. The other half have way too much confidence in speakers. It's not exactly link bait. There is good reasons behind it. But before we start, beyond the fact that they printed my face on a nice little schedule, why would you listen to me go on and on about REST? Whoops. I'm Serial Seb. That's my Twitter. It's the only way to get in touch with me. You can also catch me at the pub usually. But once upon a time, I started, thanks to Clement Vasters and an absolutely awesome presentation on service-oriented architecture, I started my path on trying to build distributed systems. And if you calculate between 2017 and 2001, that's 16 years of failing in so many ways. And then in 2003, 2004, I started resting all the things. I was resting a lot, and as it happens, I was out of a job. Rest does not pay. So because I got absolutely no money, I thought, let's just do open source. That way we'll just continue on that trend. And in 2007, I built, back when there was nearly nothing on .NET, a resource-oriented framework called OpenRaster. And I started talking about stuff I thought I knew in a lot of conferences and user groups. So I've been wrong enough, often enough, to have something to say. So I got you here to talk about mostly HTTP APIs and where we are in the industry right now. Which means a few things. I'm going to try to sell you concepts and ideas that exist, are deployed, that you can feel, touch, and look at implementations of. I'm not selling you a silver bullet. I'm not selling you the death of REST. I'm not selling you REST 2.0, because apparently a new product is claiming that. So I'm selling you the next version, which exists right now. And REST is good because if we go back to history, the web started in '91. Not the internet, but the web. Tim Berners-Lee and the other very smart guy that I can't remember the name of. In 1999, we had the first specification for HTTP 1.1, which has been with us as the only network protocol for the biggest and most reliable distributed system ever built, which is the web. And, and REST. I just killed the funny image there. And in 2000, Roy Fielding wrote a thesis that unleashed the term REST, very well specified. And of course, by 2001, people started talking about how REST is not REST and it's plain old JSON and XML at the time, which is JSON but with different brackets. And anyone knows who that is? Don Box. Don Box in a bath. I wanted to preserve you, so I kept him. I kept the picture where he still has his T-shirt, which is the first 5 seconds. I'm pretty sure Code of Conduct would not allow this anymore. But nevertheless, so the web exists already since '91. and that's REST 0.9, right? It's REST all the way until the term REST has been coined. And then we all know the REST 1.0 in reaction to SOAP, web services, code generation, static contracts, and all these nightmares that ended up all the way to WS transfer, which re-implements HTTP GET over SOAP. Because why not? The loop has closed. So that's stuff that we all started with, right? How many of you still use services like that? Well, you could say it. It's not bad. It's just old. And so back then, I was, so in 2009, I was defending the term REST very heavily. I was a little bit in my constrained view of the world. No, REST is not that. This is not REST. You don't understand REST. Stop using the word REST. Let's fight for the term REST. And as you can see, I was also not a very nice person back then. A poorly written page at that. My God, I keep all these blog entries just out of integrity, but that's not very good for marketing. And then having conversations with a whole bunch of other RESTifiers, which we used to call the people that were interested in REST. Nothing to do with style, really. Really nothing to do with style. We discussed, and I said, well, maybe we need to drop that term completely. I'm not the one that started this, of course. There was already a feeling that REST was dead as a term. It didn't mean anything. Vendors had started to implement terrible frameworks that all claimed to do REST, and so everybody changed that term. So we started talking about hypermedia. That's what I call REST 2.0, right? Hypermedia is where we start using documents and we have links, and it starts looking like static HTML in your APIs, right? How many of you use APIs where there are links in it? That's not bad, right? Half of the room. How many of you have never seen a JSON document with links in it? All right, so the other ones have made a conscious choice of not using links. Since then, a lot of stuff has happened in the industry. I don't know if you've noticed, but the HTTP world has been very excitable in the last couple of years. And they've built a whole bunch of stuff, and it's difficult to follow. And so I'm going to try to present you a partial view of all the cool stuff that exists and the stuff that people are investing a huge amount of money to make HTTP better. And as such, I shall coin this REST 3.0. And I think it should be like the HTML specification, a living thing, so that we stop versioning. For anyone that saw my talks know that versioning is evil. So of course the first question is it RESTful, right? The community in REST has always had issues with telling people what is not RESTful, and very, very hard time to explain what RESTful is. So there's a website for that. There's a great website for that called isitrestful.com. I encourage you to go there. Apparently my website is not on there. It's not RESTful. But then again, if you ask again, you will notice that the site actually doesn't care at all. And the reason they created the website is to save the millions of hours that we all wasted trying to understand if our systems are REST or not, and if we can have the stamp of approval of the term REST. So I'd like to reverse that, and I'm going to stop talking about REST from now on. I'm just going to talk about features that we want in our applications, or features that we could have and we may not be knowing the possibilities of. So we're going to talk about features, and of course, also being an agilist with a small a, because no certification. I wrote a bunch of user stories, right? So in order to stop reinventing the wheel, sorry devs, might not be an idea, not invented here syndrome, I want to use my existing knowledge, tools, and libraries, right? How many of you have written your own TCP stack? How many of you have written your own HTTP client? How many of you have ported your HTTP client to HTTP 2? There you go. The costs are increasing so much, and it's so cool to reuse something that kind of works some of the time. And that's generic processing. It's called the network effect. The more adopted a technology is, the more software we have to do cool stuff with. And so we should probably stop trying to rebuild systematically stuff, because it saves time, saves money, and knowledge gets spread, and everybody understands at least some of the stuff that exists in HTTP. And that's, of course, in contrast with the old RPC approach. The old RPC approach has an interface that you interact with that is specific to the application you're using. And so if I want to call get customer, I generate my little proxy from some WSDL file back in the days. People do that now with a Swagger Open API. And I call a specific remote procedure that usually has a fixed format, just like web services did. So then these systems evolve, and then you get customer 2, get customer 3, and then you start having code of gateways with thousands of lines of code, just passing stuff along. And of course, if I go to another application, in another business, in another team, there's another get customer, and it's not quite the same one, and I need to have another piece of information in it, right? That makes sense? We've seen that? Okay. In HTTP, the way we access information is always the same one, right? We have a request, we have a method, some people call that a verb, term from the 90s. And we can access any of the services we have over the same protocol using the same semantics. And it doesn't matter how people have built it behind, because we have one HTTP client. And that's called the uniform interface. The uniform interface, which is part of REST, and part of a whole bunch of other architectures, allow us to leverage our existing knowledge of HTTP and our existing tooling so that we can do calls to servers using exactly the same semantics. Now, of course, you can still do RPC over HTTP, but at least you don't have to implement your own network stack. And of course, that allows you to leverage tooling. Every single service you want to diagnose, you can use the dev tools, you can use Fiddler, you can use Chandler, you can use Wireshark, and it will show you the HTTP. And even if you don't know that service, because it's self-descriptive, there's enough information for you to understand roughly what is going on. Unless, of course, you use an RPC system, in which case nothing makes sense. But who would be crazy enough to still do this stuff? I'm not talking about any technology in particular that claims to replace REST. And so we want to leverage HTTP, but the next step, of course, is to leverage the formats that already exist. Again, because I can build tooling across various services that don't implement the same thing at all, but have the same semantics for some stuff. And here is a home document. It's one of the specifications that can have a lot of interest for developers. I want to document how you go on my Netflix application. As you can imagine, I may get in trouble for the trademark, but it's obviously a funny comedy reference, so the copyright laws should accept that. Fingers crossed. And so this document is the way that the first time you hit an API, you want to know where my movie list is. So I built a movie browser that wants to show me a bunch of movies and their cover. And I want to know where that movie list is. Because actually my RESTflix client can go to multiple services. Just imagine if you could have one browser for all the places that sell you movies. It would be a revolution. But that will never happen. But in theory, you reuse the same document, and the movie list is the thing that you hard code. This is your level of coupling. You say, I'm looking for a movie list. You'll notice it's a URI, but that's just because we use URIs as identifiers. So you encode just the name of the thing you're looking for in your code, you bake it, you ship it, and when you access a system, you go to the home document and you find a URL so that everyone that implements that can put the movie list anywhere they want, on any server, at any URI. Why do we do that? Well, we do that, of course, because we can start coding stuff that we can reuse across all the services that we use, some movie list, some customer service system, your own little toy project at home, and it's the same code. And that allows me to discover links in an application, whatever the application actually does, which I think is pretty cool. I'll show you another example. How many of you have seen in APIs custom errors declared in JSON? Right? I mean, you try to do something and it returns you a format telling you more or less what happens, right? GitHub does that, everybody does that. And each and every single one of them is different. And again, that means that I have to code for each of my services a different way of viewing and handling errors. So we have a problem details specification now, again, which allows any service that I use to declare what happened. So for example, in my restflix.com/things, again, this is just a name. It's not something that you go to, it's just a name. Could be a string of, could be any URI. And some of these things are specified for every single error. And then I can extend a little bit of things by putting a balance that you have, and I charge 50 REST bucks, my local money, the only one that doesn't vary on the market, for no one uses it. But it allows you to write code like that instead of catching, and this should be readable by most developers that are used to C or the C derivative languages that our industry keeps on inflicting on us. I can now have a layer above just having an HTTP exception, right? Or reading a 500 and then going to the GitHub documentation, try to understand what problem was. I can now model for all my APIs in a generic fashion, put it into a package, allow everybody to be in versioning hell as they use your stuff. But here I can have a problem exception and I can have the type so that I can actually start handling errors that are exceptional. Although, of course, this is a very bad example because people running out of money is not exactly an exceptional circumstance. Once we have a uniform interface, the advantage is we can start intercepting stuff and making intelligent actions and decisions on it. So for example, instead of littering your code with loads of logs and implementing a logging framework and all the stuff that we have to do in certain applications, well, you can actually just return HTTP. And we have an intermediary here, a little proxy, that will read the 500 error. And because it's a standard media type, it can log exactly what happened, and it knows where to put it, and it knows who to alert, because you could extend the problem document saying, please call someone at 3 in the morning to tell them that someone ran out of money. And I can log to file. And the advantage, of course, of that is that I can write 100 of services, and they can all go behind that thing. I don't need to rewrite it all the time. I don't need to add the code. It even runs in another process in a different part of the network. And the last thing, of course, is one can be written in Go for performance, and the other one can be written in web forms if you want. If you want to process things very slowly. And of course, we already know layering tools, right? We already know layers. We use them all over the web. Anyone has any idea of the kind of intermediaries that we use? No one? Load balancers, proxies, reverse proxies, CDNs. And as I showed, your own in your infrastructure, for example, for logging. Any orthogonal concern that is not related to your domain can be implemented generically across all teams, across all domains. And what is interesting is that the majority of web frameworks and the majority of languages have adopted and embraced that layering, because you find middlewares in a lot of technologies. You find them in ASP.NET Core, you find them in Node, you find them in OpenRaster, you find them everywhere. And again, it's because you want to have orthogonal concerns with generic processing over time. The next thing we want to do is to be able to update our software. And we don't want to go and version our remote procedure call with a 2, 3x or whatever. We don't want to try to do COM. If anyone remembers the beauty of versioning in COM. So in order to allow independent development of client and server applications, so that you don't have to rewrite your client every time you extend your server or change anything. So you can do half of the work, release, and do the other half of the work. Have independent clients for multiple languages and platforms. How many of you are using at least 2 languages in anything you use? Everyone, right? Unless you don't do web development or don't do JavaScript. So we end up having multiple languages, multiple applications, and I want to be able to evolve those independently because I can't have a clients team responsible for building all the clients. Well, I mean, I could, but it's very inefficient and it doesn't work across domains very well. And I want to evolve my server applications without breaking customers. We don't break customers because if we just want to fix a typo in our media type for obsessive-compulsive reasons, mostly, I'm not sure your customers are going to be very happy when you break absolutely every single one of their systems at peak traffic time, which is always somewhere in the world. So we don't break customers because we like making money, and if you break them, they don't give you money. Or REST bucks for my customers. As I said, I'm not very good at making money. So in order to do all these things, I want to build an API that can evolve. And so in the past, once we had linking, people started documenting this kind of thing. I apologize for my writing. I should have been a doctor. Unfortunately, too many years of studying. So I have my little client here, and I do what people recommend. I have URI templates. For people that have not seen that, we have little variables in curly braces, and when we want to access a movie by title in the client, we automatically put the movie title where the little brackets tell me to. Most APIs are described like that. Even the good APIs are described like that. And so this is what you encode in your clients, you deliver it, you ship it, you put the NuGet package, and then that stuff exists for hundreds of years. Because a lot of people don't update their packages regularly, right? And you want to keep on supporting them because, as I said, you don't want to break them. So my RefSix 1.0 works, people are happy, they're buying my movies, I'm making a profit, finally. And then I ship RefSix 2.0, and I just fixed a thing I didn't like with my URIs. Unfortunately, I don't control the client, because it might be the team next door, which doesn't like me, or they're in another building in another country. I don't know which one is more probable. So that makes people unhappy. So we started talking about hypermedia in a dynamic way. Instead of sharing the knowledge out of band and encoding it in our client, we discover those links dynamically in band. I go to the service gives me links, and from those links I can navigate. What else does that? What technology does that? The browser, right? HTML has been doing that for ages. It's a model we understand. And somehow when we go to applications, we don't do the same thing. Because why not reinvent the wheel? And I don't like reinventing the wheel. So when we talk about machine-to-machine scenarios, or when we talk about API development with the atrocity that SPAs are, we use links that need to be discoverable. So when you're a human being and you're in HTML, you have an intent. You go to the website to do something. And then you look at all the links and you try to find the one that can do what you want. So I'm in my movie list. I click on the movie. I'm on the movie page. I want to order. I click on the order button. Machine-to-machine scenarios are going to use the same concept. You need to encode where to go based on my intent. The thing you're going to bind to a button. I want to edit the details of a movie. And we use a relationship for that, which is part of the web platform. I have my movie for Terminator, and I want to edit it because someone said the movie was great, and I wanted to downgrade it to about okay or worse. And that relationship is going to be one of editor, because the relationship between the two, I have a movie and I have an editor for the movie. And so I describe those links. And we can do those links using plenty of new media types, like HAL, which I think is hypertext application language, maybe, I don't know. And this is a way to format your documents, again, in a standard fashion, across all your domains, across all your APIs. And we have a little underscore links that you can add to any document you return. That's going to give me a rel of editor, a relationship of editor, and then the actual URI where I can find it. And now I can discover each of my links as I navigate the application. So I hard code less stuff in my client. I have more flexibility in evolving my server. And this is at the document level, right? The HTTP is above, or under, that depending on how you draw things. But we have the same technology that is even more generic. And that's the link header that's existed for a very long time, actually since HTTP 0.9, and then it disappeared, and it's reappeared now. And the link is going to do the same thing. It's going to say that URI is actually an editor, so if you're looking for an editor, here's where you can find it. And by the way, here's my new personal HTML version called Wobble, Wobble, Wobble. I don't know why. I thought it might be funny, but I think I missed that boat. Okay, so I don't know, sometimes you get it wrong. So that's great. We can discover stuff dynamically. But really, if you look at how the browser works, the browser which does not need to be updated ever if you don't want to, and CSA Mosaic and links still work on most websites, except for the SPA. I'm not going to swear. We can start building one step further. Instead of just discovering where we go, we can even decide and discover how to build the requests. So I have a level of indirection to find where to go, and now I can also have, so this is Siren, it's another format, and you will see that it has a bunch of actions. And those actions allow me to have an encoding in my application called order movie, and that's the only thing I build in my client. And I have a bunch of fields, just like in HTML. So for example, here I can have a hidden value of 50 for the price. That's why I ship, so that the client, when it builds its request, can send that along. We've all done that until people try to build events on top of HTML, which didn't pan out. I'm looking at you, web forms. They're not the only ones. It was cool at the time. Well, we thought it was cool at the time. So you can have a bunch of hidden values, and you can also have a bunch of text. And so when the client receives the form, it blindly maps all the information it knows about to whichever format it was requested to do. So we can read and write the web dynamically, like a browser, using an HTTP client that you need to write once for the rest of your life until we break the specs, which I don't think will happen. Okay, so now we have a dynamic system. We have to update the clients less often. We don't break people. We can make money. We are very happy. Are you happy? No one is happy. Very grumpy audience. The next step, of course, is to get our system scalable. In order to scale my application horizontally, I want to deploy more and more stuff because I know that RESTflix is going to be an international success. I want my servers to function autonomously and independently. If my servers have to share state, I am limited to the scalability of the thing that they share state with. How many of you run SQL Server? Wow. I'm sure the numbers will go down eventually. How expensive is it to scale SQL Server? Those machines cost money, a lot of money. It's big machines. And the more clusters you add, the more the cap theorem applies, the harder it is to scale, the more expensive it is to scale, and then you realize that each of your web servers are becoming less and less useful because contention happens somewhere else. So autonomous components exist for the sole purpose of having independent systems that do not rely on sharing state continuously and having one source of data. They are self-contained, they communicate with the rest of the world, and those exist and have existed for a very long time. They used to be called autonomous components, and then, as we saw with REST, people like coining terms. So what do we get now? They call it microservices, because it's the new thing, right? But microservices are now serverless, where you are absolutely stateless, but you go back to the same persistence medium. So we're back to square one. So really, if you've adopted all the stuff that we've seen, right, in the web, when I order something, I go back to a credit card system that does not interact, that does not share a common data store with my application. It would be against a whole bunch of certifications, and it would be a security nightmare. So instead, we have independent services that just communicate over a network protocol, and that's it. So really, we're not talking about microservices, we're talking about micro-resources, because that's what we just built. And really, when we talk about micro-resources, there's nothing micro about resources, they're all just resources. There's just stuff that we build over HTTP, we've built over HTTP for 25 years. So we pretty much should understand how it works. And the web, just like your application, can scale better if you don't go and retrieve stuff all the time when you don't need to. And caching is a very efficient way to do that, right? In order to interact with my application efficiently, I want to avoid retrieving things over and over again. How many of you have built their own cache? How many of you use an application layer cache? All right, so you know about caching. Caching is good. Caching helps. And yet you use 4 or 5 different caches in each of your applications, because every single vendor likes building plenty of caches a little bit everywhere with slightly different APIs. And all of them having different ways of expressing caching. In HTTP, on the web, right now, and for the last 25 years, that's not true, the last 17 years now, we've needed a bunch of stuff to cache documents. And that's not just the web, right? We need to identify the document we need to cache. We need to be able to refer to it back so that we can retrieve it from the cache. So maybe you use your internal IDs. Maybe you use GUIDs. Maybe you have a URL for your document and a GUID, which is crazy if you consider that URI means Uniform Resource Identifier. So we have IDs, but we slap another one because why not? Fair enough. So we already have a way to uniformly across the whole internet, across all your applications, all your services, all your domains, a unique way to identify everything. And anything that has a URI is a resource. We also need to know how long to cache stuff, right? If I'm serving you a picture of Schwarzenegger from Terminator, the movie, well, that picture is not going to change. That picture is always going to stay the same, so I can cache it for however long I want, right? But we also need to know how to remove stuff from the cache. Maybe we posted a picture that is illegal to post because we broke copyright law. I don't know, you caught Schwarzenegger half naked in somewhere, I don't know. A picture you need to take down. So you need to remove that from the cache. And so you need a way to invalidate this stuff. Or you updated the Terminator movie file and you now say that that movie is actually pretty bad when you consider all the other ones. And so you want to invalidate the cache because you updated the movie and then the browser still sees the old version, and that's not very useful. So as most of you use caches and you implemented your own, or you use half-baked stuff that is based on objects and your grids, we recommend not to build your own cache because doing it right is pretty complicated. And as you know, there are two things in computer science and in development that are difficult: naming things, cache invalidation, and errors that are off by one. Got it? Okay, so how do we control the cache? This is really old technology. Everybody should be aware of that. We have a cache control. We can say for each document, I'm allowing everybody to cache this stuff. You can use this wherever you want, however you want, for 3,600 seconds. And I can invalidate the cache with new technology as well. This is called the invalidation through links. So, how many of you use sub-resources in your APIs? No one? One person. There is no such thing as sub-resources. People call it that because on your server you say, well, you know, there's an editor for my movie, but if I delete my movie, obviously the editor should be deleted as well. And because it's /movie/terminator/editor, people assume that there is such a thing as an implicit relationship between the two, which is absolutely not how stuff works. They're two completely independent things, and there's absolutely no way to know that one that gets deleted should mean that the other one gets deleted. No one looks at /terminator and decides that anything that starts with that gets deleted. That would be crazy. That's why it's not implemented that way. So there are links. This is a proposal. I think it's implemented in some caching software that allows you to say, well, I've just deleted Star Wars Part 1, because really that should not be on sale or having ever been produced. I'm sure you agree. And so I delete that movie completely. I want to stop selling it because I feel very bad about making money while people watch a terrible movie. And so when it returns to 100 OK, it's happy that it's deleted stuff. And it tells me, by the way, you can also invalidate the cache for the editor because that will not be available anymore. We're removing this as well. And the user relationship or invalidates, which makes everybody happy. The next thing, of course, is that I want to serve my movies. And some product vendors will tell you that REST only serves one thing at a time, and as such, it's very inefficient, and it's the end of the world, and it's unusable. And of course, that's not true, because there is no silver bullet. But we have a way to manage collections. Collections being my list of movies. I have a whole bunch of movies. And I want to retrieve those movies efficiently. So first, I can describe them manually, like this. I can create my own custom JSON that doesn't reuse anything that exists, so that on top of writing custom code, I have to write the documentation myself. Who likes writing documentation? Who's good at writing documentation? All right, if anyone is good at writing documentation, please join my open source project. Everybody will be thankful for that. But then again, I don't have users, so it's not a problem. That's not entirely true, though. So I can build my own stuff, but again, we have the same problem I've been hammering about, and you must be sick of hearing it, but you really don't want to have to re-implement collections of a single one of your domains, every single one of your servers, every single one of your applications, every single one of your teams. That was a lot of breathing. So, of course, there are formats that allow you to reuse stuff. For example, collection plus JSON. Fantastic little format. And it describes a collection. It describes a bunch of stuff. Now, it has a version identifier, which I'm not entirely happy with, but it's not my spec. And it tells you that the list of movies has a bunch of movies. It has Terminator, Terminator 2. And if you read that, then you know that there are two things that you could try to get information about. Of course, I could embed all the details and the description and do a sub-resource. But what would happen with caching? If I embed the information about the Terminator inside my collection, what happens when I go to the actual URL of the Terminator? Is it cached? Who thinks it's cached? Who thinks it's not cached? Who doesn't think? Okay. So, of course, it's not cached. Because if you embed stuff into one resource, the other ones are not visible, so you don't have good cache hits. So you should probably not do that for efficiency. Because we have other ways to do it. So if I take this, of course, there is no detail, so I need to go and retrieve each of them to have my details, which might be a little painful if I'm retrieving thousands of movies in my catalog. So this is another cool technology that is implemented in browsers and everywhere else. I can say when I return you the list of movies that you should probably, as soon as you receive the headers, and before I send the list, you should start downloading all this stuff very, very, very quickly. Because I'm going to need them. And so you put in the infrastructure the capacity to fill your cache in advance so that your code can look at the list and then do HTTP requests for each of the items as if you were doing over the network, but you're using the cache. You never leave your machine. And caches are pretty fast because even if you're using .NET, you still use the HTTP cache of the platform. And as we know, vendors try to optimize their software. If the cache for the browser was slow, you would hate them, and they're really trying to reduce the amount of time it takes to download and view cats being cute images, which is 90% of the traffic on the internet. So you'll see that this link relationship has the name preload, and of course it has to have a relationship between that link that you're preloading and the current document. And here we have the as, which replaces the link. So I'm describing that Terminator is an item as part of a collection. And so I can start downloading, because my current resource is a collection, I can start downloading each of the items in advance. And you code it once in your HTTP client. And actually, if you're using the browser, it will do it for you. You don't have anything to do. And if you're on .NET or on Java or in other frameworks, you build once the code that will do this and start use the cache efficiently. But we still want to get a little bit more performance out of all this. Because after all these competing formats that declare REST dead tell you that REST cannot perform well for those scenarios because of all those requests. Because I need to go and download each of the items independently, and while I can load the cache while I try to process the information, it still needs to do a whole bunch of requests, right? And in HTTP 1.1, we don't do that. We have plenty of servers with different DNS. We ship all the images in CSS in big grids, right? Who's doing that in CSS? There's a term for it. Can someone tell me what it is? Huh? Tiling. And we do minifying on our documents, and we do bundling. We do all this stuff, which is just mechanical crap that you have to do to have a quick page loading. So of course I want to increase my performance without having to do all this code that tries to optimize a broken protocol. And keep things simple, because simple is harder to bugger. So in order to respond faster to my clients and look like I have a really cool API, I want to increase the performance of my application. And so this problem of doing many requests in HTTP 1 is due to the way the protocol is implemented. You go and do a request, you have to wait until the response comes back. In the case of my collection, I need to wait until I retrieve the collection before I can read each of the items. It's not entirely true because that's per connection and we open 6 in the browser, but we still have 6 things waiting continuously on the response before doing the next request. That's HTTP 1.1. But actually HTTP 1.1 has a feature that mobile devices tend to implement and browsers have not been too keen on implementing, and it's called pipelining. So for safe HTTP methods, the browser can send 12 requests, for example, from my link headers for all the items, and send the 12 requests in one go. And then it will receive the 12 responses in one go. You can only do it for GET and other safe HTTP methods. But at least, you don't have to wait until the next one arrives before sending the first one. But there's still an issue with this. Until, let's just imagine that the first response takes a lot of time. What happens to the second response? It will wait, because you have a head of queue problem. I send the first one, but my server is stuck and cannot send the second one because the first one has not finished transferring on that connection. And so we now have the solution to all this stuff in HTTP 2. Who's using HTTP 2? One person? Yeah, that's about right. But it's a really cool technology. I was lucky enough to spend some time with the IETF guys and the implementers and the people from Chrome, Mozilla, Apple, HA Proxy, really smart people. I felt very stupid. I usually feel very stupid, but this was really up 3 notch. And they're investing huge amount of money. And one of the things that they're doing with HTTP 2 is multiplexing. You can now send as many requests as you want, in any order you want, and the server will respond in any order it wants, as soon as it can. And so the head of queue problem, the head of line problem that we have in HTTP 1.1 pipelining goes away. It completely goes away. That's a very efficient way to transfer information. And on top of that, all this stuff is over one TCP connection. Everything that happens through a server is through one TCP connection. Because of multiplexing, we can have parallel requests, just like we did with 6 connections, over one connection. And they didn't stop there, of course, because they want to make it as performant as possible. So they did HTTP binary. They made HTTP binary. Now, of course, that means you can't telnet from a terminal anymore with your VT100 terminal from IBM. You know, these big machines with mechanical keyboard. Anyone remembers that? Yeah. So for the young ones, VT100 is a thing you should check on Wikipedia. So they made a protocol binary, which means it's very fast. And of course, everybody should use curl or wget to inspect stuff, of course. But that means there's much less stuff happening on the wire. It's much more efficient. But of course, they didn't stop there. All the HTTP headers are always the same ones over every single one in request and response. It's a lot of bytes being wasted on the connection. There's some statistics I saw, but I can't remember the percentage. We'll just assume that it's 10% of the data traffic is actually just plumbing for HTTP. Check the number online, I have no idea. But there is a significant amount of space for small requests, which we want to, we really want people to do plenty of small requests. that increase in cost with all these headers. So they created HPAC, which is a way to compress and gzip, or it's a custom protocol that is safe and secure, that compresses per connection a whole bunch of information that is repeated in HTTP. Of course, there's a binary format. I talked about it. But the wonderful thing about this multiplexing is that, as you may know, TCP stacks in operating systems, when you open a TCP connection, starts by going pretty slowly. Right? If you look at your operating system and the network graph and you start downloading a file, everybody should see that it starts a little bit slow, and then it starts increasing the capacity to transfer information the more you download. Anyone has seen that before? Yes. People see that if you're in a Radisson Blu hotel and the internet is terrible. So that's because of the TCP window. There's plenty of mechanics that are not interesting for this talk. But it means that the longer you keep the connection open and the more you use it, the faster it becomes. And because multiplexing happens over one TCP connection, you get the maximum bandwidth that you can for a server. Really, really performant system compared to some technologies that are still in text over one single endpoint over HTTP. I really have nothing against that technology, but a little bit. But that's not just enough. As we've seen, we've done the prefetch, but I still need to wait until the whole response has been sent to start loading stuff, right? I send my collection that has all my links, but I will not be able to read the links until the server has actually retrieved the information from the database. I do my get, it goes to the database, retrieves stuff. I have to wait until it comes back to start prefetching in the browser. But I can be smart about it. There's a new thing as well called sending links early, for once they have an RFC that describes things clearly. So that's great. And it's the 103 status. So you probably know the expect 100 temporary response. When you try to upload a file, instead of waiting until you transferred 4 gigs to tell you you're not allowed, it actually tells you, I expect to get a 100 so that you can cancel before you start transferring stuff. And so you really get 2 responses. That's implemented everywhere. All the servers, all the clients, they implement that. 103 is the same principle. I do my get. The server happily goes to the database and waits. But I can respond immediately with partial headers for that response. I can start to tell the system, I've seen this stuff before. You're going to need all this. You're going to need all those links. Probably. So try to download them with whatever bandwidth you still have available. So we really maximize the usage of the tube. And then when the database comes back, I can return the document. And so you can go even faster. And we're 52 minutes in, so we are at the last slide, which is pretty cool. For me, because that means I can stop talking. We're not stopping there. And when I say we, I say they. There's a whole bunch of other stuff coming that's really exciting, that is allowing, thanks to the browsers, your smart clients and your code is going to get faster, better, more efficient. People are abandoning TCP. Well, abandoning. They're building on top of UDP, the HTTP2 protocol, which means you'll go even faster than trying to maintain your TCP connection. You'll be able to maximize massively how your connection works. As far as linking is support, we're going to have with Hydra, which is a specification using JSON LD, which is a hypermedia format, just like all the ones I showed you. A little bit more complicated, but solving a whole bunch of other scenarios. We're going to approach the capacity to write semantically correct, understandable, completely generic clients that will be able to be completely flexible, which means that you'll be able to update your clients much less. And you'll be able to keep all those horrible JavaScript clients without having to touch them, if you have such things, which I'm sure you don't, because you're all great developers that love great languages, written in 10 days. So, generic clients are happening, and of course, it wouldn't be me if I didn't start announcing stuff that may or may not happen. But due to all these technologies combining together and not being available in .NET very well, and I think we really have a very poor story on the client and on the server around hypermedia in generic terms, I've restarted OpenRaster with the help of some of the customers that are using it and are very happy with it. So expect to see me ranting, moaning, and demoing, and talking, and blogging about it in the next couple of months. I will take any questions, if anyone has questions. We have 6 minutes. Yes?
With these link headers that you can send along so clients can download, if you screw that up, you can really waste someone's mobile data plan.
So the question is, if you screw up the link headers that fill the cache, then you could screw up the data access plan on your mobile, which is very true, but the browsers are intelligent enough to prioritize. They don't have to follow the preload. They do it if they have spare bandwidth, and usually they would detect the kind of network they're on and probably try not to preload them if you're on Wi-Fi. I don't know that. I can probably ask the Safari guys if they use that, and I can probably try to figure out what browsers people on Android use. I'm not entirely sure of. Or Samsung, which have their own browser now. I'm sure they implement something like that because you're absolutely right. If you start sending them gigs of data, they're not going to be very happy. Plus, I need them to have data access plan gigs left over so they can watch the movie they bought. Any other questions? No? Okay, so this is the last slide. There will be, as usual for my talks, there will be this URL that you will be able to go to, have all the links of all the specifications I talked about. As I start blogging about some of those subjects, you will have all the links on that as well. We were at NDC Oslo. If you want to tweet about this, please do use the hashtag ReST3. I love feedback on my talks. If you have any feedbacks, you can just hashtag. I will read everything. And if they're nice, I'll retweet them. And if you're wanting to have more personal feedback, please feel free to tweet me. I would really appreciate it. My website has a huge amount of content going back since 2003, so don't judge me too hardly. I was young once upon a time. I was Sebastien Lambla, and thank you very much for attending ReST 3.0.